So what are the results? In fact, if you have this is the pure material for wood with a lot of OH groups, the after 14 days the adhesion is going up a lot. For glass also a lot. For aluminum is going up also, but less. And in all the cases we have used 0.06 of a catalyst. Such a material can be also used as a base material for instance, a sealant. And such a sealant has the advantage you can combine some materials together, and you have a certain green strength, and you have still some time after the cross-linking is happening. For instance, for double glazing. So you see you have a component, the Vistaplast 206, for instance, and you add some butyl rubber, some other cheaper APIO, carbon black, zeolite to remove all the humidity of the sealant, a catalyst, otherwise you have to wait a long time until it cross-links, and also an adhesion promoter is also used. And so what are the main formulation areas to consider? What kind of a polymer do you want to use? Do you want to use flexible polymers? Do you want to use water soluble polymers? It all depends on the TG that those polymers have. Do you want crystalline polymers for hot melt or for a pipe, for making a pipe? So you have so you have a lot of possibilities to consider. What do you want to make? Do you want to make an adhesive, sealant, or do you want to make a construction material, coating, and so on? Do you need silane coupling or only cross-linking? That's also possible. Maybe it is not always possible to make a coupling. For instance, glass, okay, you have a lot of age groups. Those materials are also possible. But for instance, polyethylene and polyprop, you cannot couple it with silane groups. It's possible after treating, after flame treating, for instance, or ozone treating, but otherwise it is not possible. So I have some remarks about the bonding. The bonding is in fact a chemical bonding and also adhesion. And adhesion is a bonding without a covalent bonding. Yeah? So it depends on different factors. Just to remind you, it depends on the softness, on the specific adhesion, and the mechanical adhesion. Adhesion is, of course, important when chemical bonding is bad. So adhesion is a function of the softness. If it's hard, and if you remove the one substrate from the other, it is possible that all the forces that you apply are focused on one narrow spot, and therefore that cannot withstand the force, and the adhesion is bad. So sometimes it's better to have a weaker polymer, a weaker material, to have a higher adhesion, and therefore it is maybe also interesting to use rather a polymer with end caps with only two silane groups instead of 3. and adhesion. Adhesion is also wetting specific adhesion. If you have a good wetting and if you have good adhesion, so an adhesion, good wetting, it can happen only if the surface tension of the adhesive is lower as the surface tension of the substrate. And you have seen also that some of these silane coupling agents are good, have a low surface tension, so that might help as well. And you see the surface tensions of the different materials are different. Teflon, for instance, has a low surface tension, and PVC has a high surface tension. So it is much easier to have an adhesion on materials with a high surface tension than on a low surface tension. And the last thing is of the adhesion is the roughness. If it's rough, then the adhesive can flow into the rough cavities to make a physical bond. So it's rather a mechanical bond. So adhesion is in fact indeed a combination of the softness, the roughness, and of the wettability. Another thing which has to be considered is, of course, the migration of the water into the adhesive when after it's applied. We saw the lamination, the laminate. If this material is completely closed and the other is also closed, then it's very difficult that water can migrate to that material, the adhesive, or that you want to cross-link. And also the material itself can be also very bad, or can be a good water vapor barrier. Can be a good water vapor barrier. So those things are also important to consider. You see the materials with the different water vapor transmission rates. Aluminum is a very good barrier of moisture, so it is in fact a very useful material. If you, for instance, coat PET with aluminum, that can be used as a packaging material for your product. And also polypropylene is also very good barrier, which it can be used as a material for your cartridges, for instance, for